What up, calculus students? Getting my sunning in, recharging my batteries before the sun goes away again. This being Monday, the nice day of the week. We are going to do the Unit 5 review, and you'll have two free response questions, only 4 parts each. I'm giving you two free response questions. However, I'm giving you lots and lots of different parts that you could see on each question. Let's remember the first two lessons about slopes, y's over x's, and then the next two lessons talked about like potentially y's and x's both changing at a moment in time. So time plays a factor. Make sure you pay attention to what you're trying to find. If it's dy dx, you're taking derivatives with respect to x. The derivative of x squared is just 2x, not 2x dx dt or anything. Yeah, back. No more whoppers. Then when we're taking the derivative of negative 2xy, we either leave it out or bake it in, but we need to distribute this negative 2. Got the derivative of first plus the second plus the derivative of the second times the first. The derivative of 4y squared. Don't forget the equals. Don't forget the derivative of 0. Now, we're not plugging in negative and 4 until we have our slope equation. So don't plug things in too early. Going to subtract the 2x, add the 2y, factor out the dy dx. Divide to solve. Now, most likely on your test, because this is what the AP exam does, they're going to say, show that dy dx equals negative x plus y over negative x plus 4y. Don't panic. That's just dividing everything by 2 at any step along the way. Okay, so you got it. Now, here's the key, though. It's when x is negative 4. Well, when x is negative 4, we can only plug in that for x. We need to figure out the y. Very, very important to remember with implicit derivatives to take the negative 4 and plug it back into the original. Same side. Get minus 32. Factor out the 4. Then factor this to get that there are 2 y's. Means there's 2 points. We got the point negative 4, negative 4. We got the point negative 4, 2. Which means you need 2 tangent equations. So remember, if I say find the line or lines tangent, I'm talking about the equation of a line, not the slope of the line. So we'd have y minus y1 equals an m times x minus x1. We got y minus 2 equals m times x plus 4 here. We're going to have to plug in these points. Plug in negative 4, 4, negative 4, negative 4. I get positive 8 minus 8. No, let's plug in more simplified one. Sorry. We'll get 4 minus 4 over 4 minus 16. So that's going to give me 0. So this guy's slope is 0, which means we have a horizontal tangent, y equals negative 4. That's the equation of the tangent line. That's not necessary to put that. It's free response. This is fine. And then for dy dx at negative 4, 2, I have 4 plus 2 over 4 plus 8. So that's 6/12, which is 1/2. You don't have the luxury of graphing, so I'm not even going to use Desmos to check. I'm just going to trust that my work is correct and kind of go from there. Very important for free response questions is to don't forget about the previous parts. So don't forget about your dy dx. You're going to use it over and over and over again. So keep it handy. When we flip to the next page, don't forget to flip back to the previous page. And we go here. Say find the XY locations of the vertical tangents. Got to know what it looks like to be a vertical tangent. Vertical tangent goes straight up and down. The slope of a vertical tangent is undefined. It's got rise, but it doesn't have any run, which means we are taking the denominator, setting it equal to 0. So our slope is undefined. But we got a problem. And this is like a very much a day 2 situation. We can't easily solve for x, and x can't easily equal a number. We have a relationship between x's and y's, which is why we need to solve for a variable. Now, what do we do? Well, don't forget, you have your original equation. Be ready to plug into it. So the original equation, that's another thing. Don't forget to go back and look back at all the stuff you were given. So x squared minus 2xy plus 4y squared equals 40. Sure that's correct. It's 4y squared. Great. We got x equals 4y, so we will plug that in for x. Eight plus 4 is 12y squared, giving us y squared is equal to 4. Y equals plus or minus 2. Don't forget about pluses or minuses. Now here's the key. We've already kind of used the system. We took this equation and we plugged it into the original. You could take this positive and -2 and plug it into the original, but it's going to give you a lot of points, and not all of the points actually work in this expression. So since we've already plugged into the original, we can actually go ahead and plug into the derivative. 4y equals x expression that we've already plugged into the original. So I'm going to plug in here to get that when y is positive 2, x is positive 8. When y is -2, x is -8. Oh, all right. Next part, talk about second derivative. So we have a horizontal tangent of the point 44. First off, you know that means the slope is 0. But the question is, what is the second derivative, and determine whether this is the location of a relative min or relative max on the original curve. So here's the deal. If you know the second derivative, you know curvature. If you know the second derivative, you know whether we're curving up or curving down. You will then know if we have a max or a min. So we're going to go ahead and find the second derivative. Again, we're going to have to use the first derivative. Negative x plus y over negative x plus 4y. And we're going to have to find this second derivative. How do you find a second derivative? You take the derivative of your derivative with respect to x, giving us that d squared y over dx squared. Same deal. Whenever I have derivatives of x's, it's just normal. Whenever I have the derivative of y's, I have dy dx. Gonna have to use the quotient rule, so the derivative of the top times the bottom minus the derivative of the bottom. Use parentheses here. Be neat and orderly. Times the top all over the bottom squared. Don't forget, you've already plugged in 4 into the derivative. We did that on the previous part. We got that the slope is 0. So whenever we see dy dx, we know what it's equal to. It's equal to 0. We are plugging in 4 everywhere. That's nice that we don't have to worry about what goes where. Everything's going to be replaced by a 4. Cool. Now, let's just look at the top. I got 12 times -1, which is -12. On the bottom, I get 12 squared, which means I get a value. This does not have to be found. You could leave things like this. This is fine. It's very important that this is fine and will earn you the point for your second derivative. However, you need to realize that this is a negative number. That's all you have to do. And then you're going to answer the question, the other part of the question. This is the second derivative. He gets the second derivative point. But the other part of the question is determine whether we have a max or min and justify. So you would say, since the second derivative is negative, the curve is concave down. At the point 4. Therefore, 4 is a max. Okay. I got to kind of talk about the points and how they're distributed. Like, you got to know that there's not much partial credit. I would probably give you 1 point for having the correct derivative. And then logical steps. You don't have to show all of your steps. But your derivative and then logical steps was worth 1 point. This is really low. Then probably a point for each of the two equations, making sure you have the plus or minus, making sure you find the slopes, etc., etc. For this part, I'd probably give you 1 point for setting the bottom equal to 0 and plugging it into the original equation. Then probably a point for the y equals plus or minus 2 and the points, maybe total of 3 points. I'm going to have to close this off and open it back up. No, I'll leave it in. Okay. This question, probably 1 point for your second derivative value, 1 point for the decision that it's a max with the justification. All right, now we have a dot moving along the curve. When it arrives at the point 4, -2, its horizontal position is increasing by 3 units per second. How quickly is vertical position changing at that moment? Great question where we now incorporate time. So we have a point 4, -2. We have dx dt is the horizontal position. Since it's increasing, we say it's +3. How quickly is the vertical position changing at that moment? Now, here's some things that you know means we need DTs. Units per second. It either tells you dx dt is 3, or you read this question and say units per second. You see that time is passing, so time is like involved. They're not just looking from left to right on the x-axis. we are incorporating time. So this is all of your indications that we are talking about dt. So we're going to take the derivative of our original curve with respect to t to see how things are changing if time is involved. So I get 2x dx dt. Now I'll have that minus 2, and I'll use the product rule, where I get dx dt y plus dy dt x. You could bake in the negative 2 as well into the product rule. It's so weird how my computer just like freezes like this. And we got 8y dy dt. So I got 2x dx dt minus 2y dx dt plus negative 2x dy dt. Don't forget to distribute the negative correctly, plus 8y dy dt. And now I'm going to plug in for my information and find dy dt. So I got the point 4, negative 2. I got dx dt is 3. This is 8. This is 4. This is negative 8. This is negative 16. Dx dt is 3. I get 24 plus 12. I get negative 24 dy dt's. I'll subtract the 36. I'll divide by the negative 24, giving me positive. What goes into 4? 4? Positive 9, 6. No, what's 12? 12. 12 goes in. Positive 3/2. What does this mean? It's like this is y's per second or units per second. Units per second. My y is increasing by this many y's per second or units per second. Time is involved. There's my answer. Hope I did all the work right. Cool. Okay, so now we're like into day 3 and 4. We're gonna have to change locations after this problem. I could sum up. Different particle travels along curves, arrives at the location such that its vertical position is decreasing. Okay, so it's the vertical position is decreasing. The change in the y is negative 2 at that moment in time. The horizontal position is increasing. So dx dt is 1. How's the angle between the x-axis, the origin, and the particle changing at that moment? Okay, so this is important. We got this point 4, negative 2. Now, I actually ran into a problem. Hey, what? Mr. Clean, exactly. You know, Hank, these are my battery cells, my solar cells. I just need to recharge. You know, we haven't seen the sun in a long time. Got to take advantage of it. And I'll tell you what I discovered earlier is that we might have to consider this y to be a negative y. But I think it might work out because I have the point negative 2, but we'll see. Okay, so we get to this point, and we got this angle between the x-axis, the origin, and the particle changing at the moment when dy dt and dx dt is negative 2 and 1 respectively, and I'm at this point. So since I have dy dt and dx dt, I'm going to pick the trig function that makes the most sense, which is tangent. And tangent equals y over x. Now, I probably should say that tangent is negative y over x. On your test, I'm giving you points in the first quadrant, which means you don't have to worry about this. And if you got a positive answer and I got a negative answer, you're good. I'm not going to stress out about it. But technically, we should be saying that is a negative y. That way, if we say dy dt is negative 2, it does mean it's going down, versus if this is a positive y, we would actually say that that y distance would decrease, which means you're getting closer to the origin. Anyways, don't stress. Just find your derivative. Secant squared theta d theta dt equals negative dy dt x minus dx dt times negative y, so that becomes plus a positive, all over x squared. X is 4, y is 2, negative 2. D, 4 squared plus 2 squared is 16 plus 4, which is 20. So D is root 20. Down when I can. Cool. So now I'm ready to plug stuff in. You got secant squared. Secant is the reciprocal of cosine. Cosine is x over d. So secant would be d over x. So secant of theta is root 20 over 4. I'm going to square that, and I get 20 over 16, which can be simplified. If you want to, divide the top and bottom by 4. Over here, we got dy dt is negative 2, so that would become a positive 2. We got x is 4. Dx dt is 1. Y is negative 2. X squared is 16. So I'll get 8 minus 2, which is 6 sixteenths. I will then multiply by 16 twentieths, giving me 6 twentieths, which is 3 tenths. I want to make sure that makes sense. If my y's are changing by that, while my x's are changing a little bit that way, I would think that my angle would be increasing. So I do like getting this positive value. If you ended up with a negative here, because dy dt is negative, you would have gotten negative 8 minus 2, which have been negative 10 twentieths. And if you got that and you got negative a half, I would have given you credit, because I haven't really talked about how if we're in the fourth quadrant, our y position, our y value would be negative. But it does make sense. It doesn't feel like my angle would decrease if I'm going down more than I'm going to the right. How's the distance changing? This will work out fine. The distance should be increasing. dt should be positive. But let's see what would happen. I actually might have to change your test after doing this question to make sure we're in the first quadrant, so everything makes sense. We take the derivative with respect to t. How do I'm doing the distance? Because it's x, y, and a d. I'm going to divide everything by 2. Let's see. Let's see if we get a positive value, because maybe this should be, oh, because it's y squared. It's like negative y squared, which is positive y squared. It doesn't matter with this. It does matter with angles. Very interesting. Very interesting. I haven't actually done this before. This type of question that I've worded this way. I've always been like balloons and ladders and stuff, but this really ties into the implicit curves, and the questions really work with each other well like this. So this widens. Dx dt was 1. Y is -2. dy dt, we said, is -2. D is root 20. So this all works out because I'm getting a positive value. Leave it like that. If you simplify, great. Just be careful. All right, the curve makes a circular shape. If the curve was the cross-section of a sphere that is growing at a rate of 10 cubic units per second, how quickly would its surface area be changing the moment the radius of the sphere is 2 units? Look at that. All of a sudden, they just changed the problem up. And they said, oh, it turns out this curve looks like a little bit of a sphere. And now we're going to just talk about a sphere. And you're not going to use the original equation at all. You have the formula for the volume of a sphere. You got the formula for the surface area of a sphere. You got that the volume is changing by 10 units. How do I know that? Because it's 10 cubic units. That's a volume. How quickly is the surface area changing? That's how dA dt, what the dA dt's value is. That would be how A is changing at the moment where R is 2. So this is when we take the derivative of both V and A. We have dV dt is 10 when R is 2. We get an expression for dr dt by dividing by 16 pi. We then plug that in here to get dA dt. Realize that the 16 pi cancels with the 16 pi. If you are worried about simplifying, then just don't. If you want to leave your answer as 8 pi times 2 times 10 over 16 pi, I can't stop you, but I will be annoyed with you because that means there's more work that I have to do to check your answer, but whatever. If that's how you're going to get back at me, that's fine. All right, I got to move so I don't sunburn. I'm fully charged. My solar cells are at maximum capacity. Oh, oh, feel like I'm shining, glistening. Ooh. All right. Oh, my computer's hot. Beauty. All right, cool. Two particles are traveling along the path of the curve. Find dy dx and find the equation of the line or lines. Change the curve when x equals -6. Okay. Start with the derivative. Take the derivative with respect to x, because we're trying to find dy dx. Y's over x's, slopes. Nothing to distribute, no product rule here. So pretty standard. Subtract the 2x and the 4. Factor out the dy dx. You get -2x minus 4 over -4 plus 2y. Maybe this is a show that. And maybe if I said it's a show that, you would have positive 2x. No, it would probably be x minus 2 over 2 minus y. This is a lame equation. I feel like I could have done better than this, but that's what it is. Yeah. And all you have to do is like divide the top and bottom by -2 to do the last step. You get that x plus 2, and you get that positive 2 minus y. All right, so there's your slope equation. Now we got x equals -6. We're going to have to find the y's when x is -6. Plug it into our original equation. Gonna move everything onto one side. This is 12. 12 minus 17 is minus 5. So now I have the points negative 6, 5. So I'll have y minus 5 equals, if I plug in negative 6, 5, I'll get negative 6 plus 2, which is negative 4. I'll get 2 minus 5, which is negative 3. So that's 4/3. X plus 6. And then for the point negative 6, negative 1 of y plus 1 equals, that'll also be negative 4. That's 2 minus negative 1, which is 2 plus 1, which would be negative 4/3. One point for the show that, 1 point for the equation, maybe 2 points for the equations. Horizontal tangents, derivative is going to equal 0. It's when you think of something horizontal having no rise, but run. So we're going to have that dy dx set equal to 0. When my tangents are equal to 0, you'll get a simple equation that x equals negative 2. We will have to take that x equals negative 2 and plug it back into the original equation. So we already plugged in negative 6, so it'll look just like this. So it'll be negative 2 squared plus negative 8 minus 4y plus y squared equals 17. We get 4 minus 8 minus 4y plus y squared equals 17. I got y squared minus 4y. I got this negative 4, and then I'm subtracting 17, which will give me negative 21. We will factor to solve this. Y minus 7, y plus 3. We get our y's are 7 and negative 3. So 2 locations where we have horizontal tangents. And there we go. Another second derivative, so this is good practice. Don't forget about your first derivative. We're looking at 2 points. Probably you get 1 point for x equals, you get 1 point for the other, for the y coordinates. You get x plus 2 and 2 minus y. We are looking for them at the locations of our points where we have horizontal tangents. Negative 2, 7, and negative 2, negative 3. We know they're horizontal tangents, so that we know the dy dx's are 0 at those locations, so that's good. So I'm going to take the derivative of my derivative, and I'll use the quotient rule. Slopes of the top times bottom minus the slopes of the bottom. So that's going to be a minus a negative. I'm going to go ahead and change that to plus a positive right away. Just distributing that negative. That's the slopes of the bottom times the top, which actually won't matter because that'll be 0 over the bottom squared. So when I plug in, let's do 2 points, negative 2, 7. Just do better here. Second derivative at negative 2, 7 equals 2 minus 7 plus 0 over 2 minus 7 squared. So that's gone, that's gone. Or you could have just figured out it's negative 5 over positive 25, which is that negative 1/5 stays. Honestly, you can figure out. Now, since that second derivative is negative, we know the curve is curving downward. Since the curve is curving downward, we would say that this point must be a max. Curve is concave down. So negative 2, 7 is a max. Let's do the same thing at negative 2, negative 3. And I get 2 minus negative 3, which is positive 5. I will get 0 again, and then I'll get positive 5 squared. So it ends up being positive 1/5. There's like a lot of symmetry going on here. So like getting like the opposite of the same value, we should not be surprised. I believe this equation is just like an oval. So it's not even like rotated. So like lots of symmetry. So lots of similar answers. So that means the second derivative is positive, which means we are curving upward. The curve is concave up. You'd write this an entire statement, which means negative 2, negative 3 is the location of a min. How do I know that? Curving upward, horizontal tangent. There you go. You can see it. Versus curving downward, horizontal tangent, max. All right, cool. We're still traveling along this curve. When we arrive at this position, the y position decreases by 2 units per second. How is the x position changing at this moment? So since we're continuing to move along the curve, we will use this curve. And since we have per second, it should say as time passes, but you'll like be told, you're going to be taking the derivative with respect to t. Whoa. I probably am going to go back and double check that all my answers are correct. So I get 2x dx dt plus 4 dx dt minus 4 dy dt plus 2y dy dt equals 0. I got the 0.32. I got dy dt is negative 2. What is dx dt? All right, so I got 2 times 3. I should divide everything by 2, honestly. You don't have to. So I'm not going to because none of y'all are going to do that. So I got 2 times 3 times dx dt. I got 4 times dx dt. Got minus 4 times dy dt. And then I got 2 times y times dy dt. So I got 6 dx dt's plus 4 dx dt's plus 8 plus 2. Ooh, minus 8. Uh-oh. Dx dt is 0. Is dx dt always 0? I probably shouldn't have said minus 2. Yeah. I mean, but that's fine. It's good to get an answer like this sometimes, where we'll get dx dt has to equal 0. How is this x position changing at the moment? X is not changing. The rate of change is 0. So, I mean, great answer. I feel like 3 2 is probably the location of a vertical tangent if that's the case. We'll come back and say. I think this point 3 2 has to be the location of a vertical tangent because for there to be vertical motion but no horizontal motion, we're just going to be moving up and down. We're not going to have a left or a right. Okay, another particle arrives at this point and veers off the path of the curve. Okay, so it's off the path of the curve. So we are going to just say, hey, we are at 2, -1. And again, I should not be in the fourth quadrant. But I will make sure we are in the first quadrant on your test, okay? So that you don't have to worry about the -y. It's an interesting situation. We got the horizontal position increasing by 3 units per second. You got the vertical position decreasing. So since it's the vertical position, that's why we really need to say that's a -y. Again, don't worry, guys. I'm going to give you first quadrant so that everything makes sense. When you say dy dt is negative and you say this is a positive y, that means you're getting closer to the x-axis. But I actually want to discuss like going up and down and stuff like that. Anyways, how quickly is the distance between the particle and the origin changing? So I'm trying to find how quickly this is changing. We have a Pythagorean theorem. These questions are the ways I'm going to ask you about triangles is like origin and a point, and the point is moving. How is the distance between the origin and the point changing? You have a Pythagorean theorem. X's, Y's, diagonals, D's. So 2x dx dt after dividing by 2, 2y dy dt after dividing by 2, 2d d dt after dividing by 2, x is 2, dx dt is 3, y is -1, dy dt is -4. This is 4, this will be √5. D is always a positive value, so I think this actually works out. We don't have to worry about -y in the Pythagorean theorem because it's like -y squared. So it's positive y squared. So anyways, we don't have to worry about that. So this is 6 plus 4, which is 10 over √5. If you want to simplify that, be my guest. Horizontal position is increasing, vertical position is decreasing. Since I'm moving to the right, obviously it's getting further away from the origin, but it's not guaranteed. So just always do the work. Okay. How's the angle changing at that moment? Okay. Again, since I have dy, dx dt, and dy dt, and honestly, since I have dd dt, I could do whatever I want. But since I was given dx dt and dy dt and it doesn't have a root, I'm going to use tangent to see how this angle is changing. Giving me secant squared theta d theta dt equals dy dt x minus dx dt y over x squared. I have the secant of theta, which is d over x. D was √5. All x was 2. So this becomes 5/4. Again, doing that, secant theta would be d over x, which is √5 over 2. Squared becomes 5/4. Just write down the other information. We got the point 2, 1. We got dx dt is 3. We got dy dt is -4. So dy dt -4 times x minus dx dt 3 times y over x squared, which is 4. So if you'd like to have a fully unsimplified answer, and get Mr. Messner frustrated, you have something like that. If you'd like to help me out a little bit, you put it as negative 11 fifths. This does make sense if, this is when I should have had this as a negative y. So I'll accept this. This is good. If you have this as a negative y and this is a negative 1. Oh, wait, we are at the point 2, negative 1. Oh, okay. So since this is a negative y, this should be a negative dy dt. So let's see what that looks like. I think it makes sense for our angle to be decreasing because I'm going up and to the right. No, I'm going down and to the right. I'm going down more than I'm going over at this moment. I think my angle should be increasing. So I will accept this answer, but I don't like it. But like again, I'm gonna put things in the first quadrant so we don't have to worry about this negative y in our tangent formula. So I hope if you're just copying this down, you rewind the video a little bit and talk talk about why. Like we probably would say this is a negative y and this is an x, and this would be positive 4 times 2 minus 3 times 1 over 4, which is 8 minus 3, which is 5/4, which means my angle would be increasing. So on the test, we are going to be in the first quadrant, very similar to the homework, page 1. Also, yeah, very much see the homework page 1. Don't worry about the negative y. But if you're doing a tutor and maybe your tutor's like, oh, it should be like this. All right, last part. The curve makes the base of a cylindrical block of ice whose volume is pi r squared h. The block of ice melts in such a way that at a moment in time, when the radius of the cylinder is 5 units and the height is 6 units, both the radius and height are decreasing by 2 units per hour. How is the volume of the cylinder changing at the moment? So at the moment in time when the radius is 5 and the height is 6, both dr dt and dh dt are negative 2. Just throwing this at you, just so you're prepared, you may have to use the product rule. You may have a cylinder, you might not have a sphere. Okay? Whether you pull in the pi or not, it's up to you. We're taking the derivative. This is very much like a day 3 question. I'm throwing this in for day 3 stuff. Derivative of r squared times h, product rule, plus the derivative of h times r squared. We have the pi. dv dt would be pi 2 times 5 times negative 2 times 6 plus negative 2 times 25. Leave that as your answer. If you'd like to simplify, you can. Negative 120 plus negative 50. Negative 170 pi units per hour. Units cubed per hour. That's good. dV/dt is negative. That means V is decreasing. My volume is decreasing because we got this block of ice that seems to be melting. If the block of ice is melting, uh, volume is decreasing. If volume is decreasing, the derivative is negative. The rate of change is negative. Okay. All right, let me go back and check some of the work and see if we're correct. Tab. Cool. Yep. Yep. Good start. Vertical tangents. 8, 2, 8, -2. That looks good. Okay. 4, 4 looks to be a max. That's good. If we get to the point 4, -2, and the horizontal position is increasing, if I'm going to the right along this curve, it looks like my y position is increasing as well, and I get this positive dy dt. Good. So it's kind of like if I get to this point and I go right, I have to be going up because it looks like I'm going up and to the right. So we kind of see that if my horizontal position is increasing, it looks like my y position has to increase. This is tough to be able to see. Same with this. So we're good. All right, let's go to the other one. X squared plus 4x minus 4y. Plus y squared equals 17. Okay. We got -6, 5, and -6, -1. So we got y minus 5 equals 4/3. X plus 6. That looks good. We got y plus 1 equals -4/3. X plus 6. That looks good. We got horizontal tangents at -2, 7 and -2, 3. Yep. We got -2, 7 as a max. We got -2, -3 as a min. -2, 7 is max. -2, -3 is a min. That's good. Okay. When we get to the point 3, 2, 3, 2, look at that. Great, 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 great situation. We say if the y position decreases by 2, if I'm going down, well, I'm not going to the left or to the right at all because I'm at this vertical tangent. You would talk about if you take the BC stuff, how you could look at dy dx, dy dt, and dx dt at that point and figure out that dy dt over dx dt is the same as dy dx. It's another way of getting that answer. Part E, we're all set about. Just make sure you know we're going to be talking about the first quadrant. That way we don't get two different answers. I'll make sure you're in the first quadrant. and then make sure you use the product rule, and yeah, that's good. So this is a good, these are good problems. This is preparing you well. Don't mess up on the first derivative, but you'll have a show that. Uh, anyways, you guys are going to be ready, so you'll do well. All right, peace.